and we are ready to start the first session of the WHA biomass fuel quality on wood pellets specifically. Today we're going to go have a webinar with two presenters, where we are first we will start with Mike from the Wolfson Center, who will have stepped in for Matala, and he will be presenting on the latest technical methods for testing pellet quality and key findings. Afterwards, Bruno Pryor will do a presentation on the kind of understanding of the EN Plus handbook and pellet delivery, and then we will have a Q&A session at the end. We estimate that each presentation will probably take around 15-20 minutes, which would leave at least 20-25 minutes for question and answering. In terms of how webinars work the best, we will give Mike controls over to present his presentation first, where every attendee will be muted, and the same thing will happen then when we switch over to Bruno Pryor. So if you have any questions during the webinar, I would encourage you to write them down at the in the menu bar at the right, where you can both activate the chat or the questions, and we will then go through those when we have finished the two presentations. If you have any questions for how the webinar works, or have any other things, also please feel free to write them in the chat window, and I will make sure that we fix any issues that are now. But now I'll let Mike, who gets started with his presentation on testing of pellet quality, and I'll unmute him now.
Right, good afternoon everybody. Now let me just put my PowerPoint up here, which hopefully you should be able to see now. Can somebody just confirm that they can see my slideshow okay?
I can see it, yes, correct.
Right, hopefully everybody will be able to now then. So yes, this presentation was scheduled to be given by one of my researchers, Murtala Abdul Mumani, but he's had to go and do something else this afternoon, so I'm standing in for him. Murtala's a PhD student working at the Wolfson Center, and he's been working for the last 4 years on wood pellet degradation, how to measure it, how to characterize it, and how to predict it. Just a brief word about the Wolfson Center. The Wolfson Center is part of the engineering department at the University of Greenwich, and we specialize in materials handling with all sorts of different bulk solids, so not only for the power industries, but we work for minerals, foods, and lots of other industries as well. But obviously biomass is a key thing at the moment. Biomass a lot of our work is involved with biomass, and particularly wood pellets. So I'll be talking a little bit about some of the principles of wood pellet degradation in order to help you to understand a little bit closer the need for good characterization methods, what a good characterization method is likely to involve, and we'll be talking about the relative merits of the characterization methods currently available for pellet durability index. So pellet degradation, why does it matter? Well, the reason why it matters is very straightforward. First of all, poor combustion. If you have with the average pellet boiler, the pellet boiler works by having a small hearth on which a pile of pellets sit, and good combustion relies upon the air being able to permeate through the gaps between the pellets. If you introduce a lot of fines and dust, then those gaps get blocked up, so the pellets can't burn properly. Because they can't burn properly, the result is high levels of smoke, soot, clinker, and indeed unburned and wasted fuel, which means that you need to de-ash the system very frequently. Now, I should say not all boilers are equal. Some boilers can tolerate large amounts of fines, some are relatively intolerant. So some customers will care and be very concerned about level of fines, and others won't. That's something that we have to be aware of. The other problem, though, is that the more fines you get, the more you get what we call segregation of fines. Segregation of fines, what tends to happen, this is like the fruit in your breakfast cereal. When you tip the breakfast cereal out, the first few bowls you get loads of fruit and not so many flakes, and as you get down to the bottom, you find that there's not much fruit left. You've only mainly got the flakes left. Well, it happens exactly the same with pellets and pellet fines and dust. And what tends to happen is that when you put pellets into a store, you inevitably create some fines. But what happens is that most of the times you discharge high levels of coarse pellets and very little fines, because the fines tends to percolate towards the bottom. And it's only when you get towards the end of the discharge that you then find large quantities of fines coming through. And of course, the more fines you have initially, the more segregation you will get as well. If it wasn't for segregation, then the level of fines that we see in pellets in stores would not be a problem. But what tends to happen is it's when you get towards the end of the inventory, that's when you get a complaint from a user, because that's when they see all the fines. So you need to be aware of the fact that fines become concentrated. So I just need to yeah, that's right. Sources of pellet degradation. There are really four main causes which we see in the handling of pellets. Pneumatic conveying, particularly pneumatic conveyors that are not optically configured. For domestic and small industrial users, most of our pellets are delivered pneumatically. They're blown through pipelines from tankers or tipper blowers into the store. And it's during that blowing, particularly if the blowing is not taken care of very carefully by the driver, that you get a significant amount of pellet breakage. That's where most of the pellet breakage happens. In large stores, you may have, in big silos for instance, you may have large freefall distances, but that tends only to be relevant to very large installations. High stresses in storage vessels may be an issue. A lot of people think that pellets get crushed if you have a very tall stockpile. They don't. It's not the crushing from the material above. It's, for example, stresses caused by augers. So if you have an auger without a shedder over the top to keep the pressure off it, then that will tend to grind the pellets. And then transfer points and vessel interfaces. So interfaces again between the storage vessel and the auger. These can also cause enhanced pellets degradation. But just to recap, pneumatic conveyors are where most of our degradation occurs. So in terms of large-scale handling, during transport, during conveying of the large batches of pellets, which we tend to mostly import these days, we get a certain amount of pellet breakage. However, EM Plus handbook, EM Plus standard, defines that that must be screened out at the time of loading the final delivery vehicle. So the degradation that happens in these stages produces a loss of material, which of course is a loss of value to us, but nevertheless should not find its way through to the user. Just looking at some pellets before and after handling, we see pellets over on the left here, so you can see what I was saying about because there's very little fines, you've got big gaps that air can get through. Over on the right hand side, after handling, you can see the amount of fines there blocks up those pores in the structure, thus preventing air permeation. Now if you look at the pellets on the left here, one of the things that you will see is around the ends of these pellets, particularly the trailing end where a pellet goes through the die, you have a concave end. On the other end you've got a convex end. That concave end leaves an area of the pellet which can very easily be knocked off in handling. And it's normally the impacts as the pellets flow that then knocks those ends off that causes the problems. Now in terms of, I just need to talk a little bit about pneumatic transport. There are different modes of pneumatic transport, but when we are delivering pellets from a tanker or a tipper blower to a store, this is the mode of flow we use, which is called dilute phase conveying. The pellets need to be conveyed with a high enough air velocity here that they convey largely in suspension flow. In industrial systems, we sometimes use these modes of slug flow to actually reduce degradation. But in our tankers and tipper blowers, we don't have enough pressure to get a reliable slug flow. So if you're using a tanker or tipper blower and you get to a situation where you've got slugging, you'll then get a big surge in pressure. The slugs will blow through at high velocity and do a lot of damage. So we have to keep away from slug flow in our tankers or tipper blowers. This is what we want here. So we're talking air velocities typically 15 to 30 meters a second. That means the particles are moving more or less the same speed as the air. And every time they hit a bend, of course, when they hit that bend, that's when they sustain damage. So we have particles here coming along a pipe. Of course, the pellets go straight on at the corner. They hit the wall, slow down, and then they're reaccelerated further down. So it's in this impact zone here. This is where most of the degradation happens. Now, obviously, the more bends you have in a system, the more times this happens, so the more degradation you get. The higher the airspeed, the higher the air you use, the more degradation you get. You get a similar thing at the end of the pipeline where the pellets hit the far wall, so you need an impact mat there. So that's a little bit about the basics, as it were. Yes, impact velocity. The particle damage rises to particle velocity between a power of 2 and 3. So even small savings in airflow can produce big reductions in degradation. I'm going to skip over that slide. One of the things to remember is that because air is compressible, as you go along a pipeline, you can see the pipeline here, as you go along the pipeline, the pressure falls. Our pellet blowers typically blow it up to 1 bar gauge, and with ambient outlet pressure, you've got roughly a 2 to 1 change in pressure, which means from the pickup, the pellets accelerate through the pipeline. They're going fastest at the end, which is why the impact mat is particularly important to cushion that final blow. In industry, we quite often actually use what we call a stepped bore pipeline, where we make the pipeline bigger part way along to reduce the air velocity. Unfortunately, that is unknown in the pellet industry. So turning to characterization, we've done extensive work comparing 3 different types of degradation tester. The 2 commonest types, which are most widely used and for which there are standards, are the so-called tumbling box tester and the ligno tester here. With the tumbling box tester, the pellets are put in this metal box. The metal box is on a motor here. It's turned over and over for 500 revolutions. You take the pellets out and you see how much fines drops through a sieve of 3.15 millimeters. And the pellet durability index is the percentage of pellets that survive. So typically standards will often quote 98.5% or something like that. The ligno tester works in a different way. You put the pellets in this little basket and you have an airflow coming in here. The airflow jiggles them around in there, bashes them into the side, and the fines go through the grid, and then you take the fines out of the drawer at the bottom. So it's an easier and quicker machine to use. We also tested a tester like this. This is a rotary impact tester, which we use widely for characterization of other materials for degradation, but it's not historically been widely used for pellets. This is a rotating disc. You pour the pellets into the middle of this rotating disc. As the disc spins, so the pellets are thrown out against these targets, and the broken pellets are caught in the bottom here, and again you then sieve out the fines. The reason for this rotary tester here is because we've developed this to specifically simulate what happens in a pneumatic conveying system, where the particles are thrown at a bend at a controlled velocity. So having tested these different testers, I think one of the things that is immediately obvious when you look at this, the mechanism of what is going on, particularly in this tester here, bears little or no relation to what happens in a real conveying system, where the pellets are going along at high speed and hitting bends. Here they're just tumbling gently over one another. The ligno tester, you might think, would be a bit closer to what happens because the pellets are moving with more energy. The rotary tester, as I say, was designed specifically for the purpose, but the rotary tester does not have a current standard. And we correlated against blowing in a full-scale test rig. You can see here where we had a tanker, we blew into a store and we sieved the pellets received in the store. Different types of pellets that we use I won't go into in great depth, but what is important here, this is the mass of fines versus the sieve size for the different tests. So if we look at the actual blowing test, this was the blue line. The blue line is here. Bearing in mind these pellets all start with everything above 4.75 millimeter. There's 4.75 millimeter here. And you can see that after blowing we have something like 2%, 2.5% that passes a 4.75 millimeter sieve. Then we have a smaller amount here in the 3.15 to 4.75, 2.36 to 3.15 and 1.16 to 2.36. So this is the size distribution of the fines after blowing in the real system. And you can see the grey line here is the size distribution after testing in the tumbling box tester. And you can see that what's happened in the tumbling box tester, it's generated a lot of very fine dust, but very little of the coarse material up here. The fact that we've got a completely different size distribution between the blue line here, which is the real blowing system, and the grey line here, which is the tumbling box, tells us that what the tumbling box is doing is totally unrepresentative of what happens in a real blowing system. The single impact rotary tester was the caramel line here, and you can see, not surprisingly, that follows closest to the real blowing test, and the ligno test is somewhere between the two but nearer than the tumbling box test. This is the same data but just looked at in a different way. Size distribution here after blowing. You can see with the impact tester is very similar. Ligno is somewhere near, tumbling box completely different. So just to conclude, comparative evaluation of different PDI measurements from the three testers. One of the most important things to understand here is very little correlation between the PDI reading that you get in the tumbling box and what you see in real deliveries, because the mechanisms of breakdown are totally unalike. So measurements of PDI using the tumbling box tester, in other words, do not give you any guide to the amount of degradation you might get in a real handling system. The other thing is, when we looked at the PDI measurements across a range of pellets between the tumbling box and the ligno tester, they do not correlate, and they are certainly not interchangeable. So if somebody gives you a PDI value, you absolutely must be sure whether it was obtained from tumbling box or ligno test, because if you put the same pellets in the two testers, you get completely different PDI values. Okay, I've talked about this. The problem with the tumbling box is that it only just gently brushes the surface of the pellets. The ligno test is a bit better. The rotary tester, we found, not surprisingly, gave the best result. And if you're really concerned about pellet degradation, then I would say for testing it, for evaluating it, or if you're thinking of buying samples of pellets or buying pellets from different suppliers, I would strongly recommend the use of the rotary impact tester. The downside of the rotary impact tester is that we do not yet have a recognized standard for that test, so it's not widely available. Okay. If you want to know more about this, UK Pellet Council is running a course which I'm actually leading. This runs on a regular basis. The next one is in Doncaster on the 12th of January, and this is aimed at pellet delivery drivers, also QA personnel, manufacturers and retailers of pellets. There are places still available on this course, and if you would like to come along, I would strongly recommend it. Contact details are here, or just contact Frank or myself in the first instance. And that's as much as I wanted to say, so I'm going to wrap up there. Hope I haven't run too long over time.
Good. Thank you very much, Mike, for that presentation. We will now continue the webinar with switching over to Bruno Pryor. And let me just switch over to his screen now. And Bruno Pryor should now be able to be the presenter, and I'll unmute him. There you go, Bruno. And you are welcome to inform the rest of the attendees who is attending as well. We wanted to do that from the beginning, but I forgot to do that.
That's great. Thanks, Frank. You may have had other people join, but I asked Frank because I think Mike and I can't see the list, so he's given me the list, and I think it's useful because I think the WHA probably envisaged this as educational, but if I tell you the list, you'll understand this is now much more useful as a discussion. That's pretty much the great and good of the industry, so this is not educational as far as I'm concerned. I will try and adapt. Those who know me will know I'm usually quite provocative anyway, so we'll try and make this more of a discussion, less of an education. Let me just try and fire up the slides into full screen mode. Right. It's a thought that occurred to me recently when I was trying to understand. There's always been this gap between the way that installers look at fuel and customers look at fuel and suppliers look at fuel. And I think maybe a way of illustrating the confusion is to think about pellets more like gas or coal. You could say gas and oil, fairly similar. But gas is a very consistent fuel. For those who've ever been involved in injecting gas into the grid, you have to go to great lengths to make it near enough identical to what's in there. And because it's extremely consistent, that means that you can have very simplified low-cost equipment and installation. So it's a mass market, domestic scale product, and you can have automatic feeding at small scale without excessive cost. Coal, on the other hand, has very wide variations in its characteristics. That means it's much harder to handle. And so really, if you're going to spend the money on handling that, it needs to be at quite a large scale because of the cost of handling something much more complex. And that means really, historically, small coal systems have near enough been hand-fed. But when you think about pellets, of course, we've tried to be somewhere in the middle. So we've charged people quite a lot of money for the equipment, but we put almost no thought into expertise on the fuel handling. So we've treated it as though it's gas coming in, but charge people for coal-scale boilers, but gas-scale fuel handling. I think we need to think about whether we really can standardize pellets to the extent that they're gas and you can have simplified systems, or whether we should recognize that pellets really, if you're going to do small scale, should be hand-fed because of the complexity of handling them. Just briefly, I assume because of the people who are on here, you all know what quality is about, so I don't think I need to talk about that much. You should know that quality is not just about the production, it's about the whole supply chain, because you can have very good pellets coming out the factory and then destroy them in the delivery. And it's not just about a spec, so quite often people will want to see analysis and say, well, that meets the spec, that must be fine. It's about the procedures that ensure that it continues that way, because you can see analysis and it's got nothing to do with the pellets that you're actually receiving. And for anyone who doesn't understand the different terminology, there's a page I've linked there that you can go and look it up. Again, I assume everyone knows this, that BSL is not relevant to pellet quality. To be fair to BSL, they have now clarified that on their website. DIN Plus and O-norm are long defunct. O-norm now is effectively the European standard. DIN Plus exists in Germany, but not the UK. Scandinavian standards used to be relevant occasionally with sort of boilers, but again, not applicable here. And Woodsure, I tried to encourage them to do a competing pellet quality scheme, and they weren't interested. So they are not really pellet quality. They defer to N+. So we've only got N+, although if you look at N+, it's very non-specific about the management systems you would implement. It just says you should have them. And therefore one might say that N+ ought to be complemented by ISO 9001. But I believe that's fairly unusual, and that's just the tip of the iceberg I'm going to go on to in terms of the problems of N+. So is N+ actually an effective way of guaranteeing quality? And N+ focuses on particularly producers and traders. You've got different certification for the different types, and obviously if you're a producer trader you certify for both. And I would argue broadly N+ is okay, it does a reasonable job for producers, but it's pretty much useless for traders. So if you look at the number of producers, there are 4 certified in the UK at the start, or near enough. I don't know if Land Energy were quite at the start, but near enough. and then 3 small ones have come on since. But there are those like hot stovies and so on, remind me of 3F as well, who haven't got certified because they're not able to. And that shows that there is a standard that if you can't meet it, you don't get certified. Traders, on the other hand, we now have 38 of them, and 31 of those were certified recently. And it's a struggle to think of any that aren't certified. And that says to me that, realistically, it's a rubber stamping exercise. It's the lowest common denominator. Now, most companies would feel that you probably can't afford not to be N+, because people would wonder whether you can do the quality. But I would say, okay, it's necessary, but it's not remotely sufficient. It's not telling you much that's useful about the ability of a trader to supply quality fuel. Well, I'm sure you all know these parameters. There's a few things you might pick out. Calorific value, some people claim they've got higher calorific value. I would say the main factor in that is moisture content. Most people's moisture content is pretty similar, as long as it's softwood, and therefore it's mostly bullshit that the calorific value is generally going to be about 5 megawatt hours per ton. And the way people make those false comparisons is to look at gross calorific value or dry as opposed to as received. The factor that may come into it would be efficiency, which would be more down to the quality of the fuel. In other words, the amount of fines will affect the boiler efficiency. And if you were testing heat output, that might actually give quite a meaningful difference. But the CV, the innate CV of the fuel, I don't think changes very much. Bulk density, we all know, varies quite a lot, which explains why a lot of customers get very confused when they're convinced they get X tons in their store, and you find out on a delivery that they actually are getting Y, and they're convinced they've been shortchanged or done well out of it. Ash deformation temperature, most of us are fuel people, so there's really only Athol. I would, on the equipment side, I would comment about how people need to, a lot of installers seem, or boiler manufacturers seem to think that you would assume that you've got lots of headroom on 1200. They actually should assume exactly the opposite. They should design so that they're intending to run well below that limit, so that when they get hot spots it doesn't slag up. But I think they all assume that they can run at just below, or not all, but some high temperature boiler manufacturers assume they can run just below that and that they'll never get any hot spots. Of course, that's nonsense. How are we doing on time? Size. This is the area that I think is fun. It's inadequate in the way that it's done at the moment, in quite a different, quite a range of ways. So if we, where should we start? If we look at the fines, which is an aspect of size, again, you will all know the difference between the fines limits for bulk and the fines difference for bags. Most installers don't seem to, and you've probably all experienced where an installer has said to you, oh, this system's running fine on bags, so the problem must be the blown pellets, and they think that the characteristics will be exactly the same. Of course they're not. They will have more. They will have higher fines, and that goes back to the point about is it gas or coal. There's also that difference between the loaded and the delivered fines, and again, a lot of confusion amongst installers, which we can't talk about here because we've only got Athol and he does know about this. The length, I think, is interesting. Some of you may know we've had an overlength problem this winter. We aren't the only ones who've had an overlength problem. There's well, there's one manufacturer in particular who had a problem, but we've more recently had a few others as well. If you speak to manufacturers, it'd be interesting to see what they say when we go to open mic. I think they will say no one can guarantee 0% over 45 millimeters. You will occasionally get a long one getting through, but installers will say, oh yeah, but one long one can block my suction pipe. And the industry needs to work out what it'll do about this, but at the moment it's got its head in the sand. The standard does not work as 0% over 45 millimeters because it will happen that you get a long one and customers will think that something's wrong and the reputation of the technology suffers as a result. The industrial standard would have 99.9% under 45 mil, and I would argue that the non-industrial standard should do the same thing. An interesting omission, I think probably a crucial omission, is the size distribution parameter. If we think what Mike just said about the analysis he did on the fines on a whole load assessment, Actually, it was the stuff over 3.15 that he was getting far more of. I don't know why 3.15 was ever chosen, but to a customer, to a boiler system, a 4 mil particle isn't much better than a 3 mil particle, and we're getting a lot more of it. But there's no limit on this at all. If someone turned up and delivered a load that was entirely 4 millimeter particles, that would be compliant. And I would argue there probably should be a size distribution parameter. You might do it simply as an average length parameter, so the average should be greater than 10 millimeters or something, or you might do that no more than X% was below Y millimeters, so no more than 20% was below 6 millimeters, for instance. It seems to me a very great weakness in the standard. We do see even now some confusions about what the length limits are. A quite well-known installer said to us very recently that in their view the normal specification, length specification, is 2 to 3 centimeters in complaining about a supposedly overlength load. This is the photo that they sent. You can see there is one overlength. All the others are well within spec, but in his view that was problematic. There is an interesting question of how one defines or how one tests for overlength as well. Is it if you find an overlength pellet in the load, it's out of spec, or is it actually if you find an overlength pellet in the sample, in the reference sample? I know different suppliers take different views. We've taken the view that if it's 0%, then one out of spec is out of spec, and we replace full stop if one is out of spec. I know other installers will say, well, if there isn't a long one in the sample, it's tough luck, and that again will lead to great unhappiness and damage to the reputation of the industry. There's nothing in the standards that says how one should screen other than that, well, it should be able to get down to 1% in day-to-day use. But what is day-to-day use? There really ought to be something that says, well, if you're going to screen pellets that start with 5% in there, you've got to be able to get down to 1% at a decent flow rate. So the systems that we've typically seen can cope with either a low fines content at a reasonable flow rate or have to run very slow to deal with a higher fines content. Now, if that's coming out of a factory, that's fine, because the pellets in the stockpile at the factory are probably only 1 to 2% fines, and it'll clean it and ship it out fine. But if they've been imported and they've gone through loads of handling stages, or if they've been shipped around the country and they're native, there'll be much higher fines, and you need appropriate handling systems, and we're not actually seeing those go in. Now, some people might say, it doesn't really matter. The standard doesn't need to say how you do it, because it says here's the limit, and it's up to people how they do it. As long as they achieve it, who cares how? But how do we know they're actually achieving it? So the standard says you'll take a reference sample, and that is how we decide whether the fines were within spec, or the fines at loading were within spec. Were they under 1%? But this is, I think, one of the worst things that's going on at the moment. The N+ says that the reference sample should be taken during the loading process, preferably from falling material. Well, yeah, okay, preferably from falling material. But actually, if you take a scoop from a belt, which is how 90% of people are doing it, it is completely unrepresentative. The fines sit on the belt, the pellets sit on top. You take a little scoop and you've got mostly pellets. That is not necessarily representative. But you've got a sample which, when a customer complains, supposedly shows that the pellets were under 1% when they probably weren't. What does the customer do? Just going back to the length, sorry, this was a little diagram I drew. The length, the 45 mil thing is a false assurance anyway, because this is a drawing of a 50 mil pipe with 40 mil pellets bridged across it. So the thinking that if your pellets are under 45 mil, they won't get stuck in a 40 mil in a 50 mil pipe is an illusion. They can perfectly easily do, because they don't have to bridge across the middle. So this is a major loading out site, and a very common system. I dare say quite a lot of people have seen these. This is an Andritz centrifugal screen. You can see the head of the conveyor there. There is no sampling system. There's no gantry that someone could stand up there and take the sample safely and do all the other things you should do. But this is the typical way that's done, because it was done at the factories and probably was fine at the factories, but is not adequate where the pellets are imported. And we snuck in to check this one, and that is what we found on the belt after the screen. Yeah, it's obviously loading out at too high a rate and the screen is not large enough capacity. But it doesn't matter because they were taking tiny sample bags, probably using 1 or 2 scoops, whereas you should take at least 11 increments to make a sample. And if anyone complained, they'd be told that's fine. I don't need to cover durability. Mike's covered that in detail. For what it's worth, and obviously it's not worth very much on the PDI test, we think 98 is fine if it's coming out the factory, going to a customer, but it's not adequate. So 98 durability is the limit in N+A1. But we think if you've got imports, it really ought to be 98.5. But I don't think there's a need for 98.5 across the board because although the British pellets tend to have a very high durability, it wouldn't be necessary. It would be perfectly good at 98.2 going direct to a customer. And again, I assume people are aware of this. There's a trade-off between durability and length, and the reason that we got some pellets with overlength problems this winter is they've got their durability up to about 99.2 and they didn't break on the breaker bar. How am I doing on time? Better off having more time for conversation. It's very difficult doing this when you can't hear what anyone else is thinking or saying. Custom site conditions aren't relevant for this because we're talking about fuel quality, but obviously we all know that the site conditions will probably be the biggest factor in how the pellets actually get into the store intact. So N+ rules on storage and loading out. It says you should be protected against the elements. Well, I've seen N+ certified sites where the loading hopper was inside and the conveyor popped out through the wall and the loading out point was outside because you need a high building. People don't want to pay for a high building to load inside. So I don't know how that passed the audit, but you know they're out there. It requires weekly inspections. What it doesn't require anymore since version 3 is a visual inspection on every loading, which seems a strange thing for them to have removed. But of course, visual inspection requires a gantry, and it may have been considered inconvenient because gantries are, again, that requires proper investment to supply it, provided at the site. Otherwise, most of that is relatively straightforward. But for the delivery, the UK has decided to pretty much go its own way compared to the rest of the N+ nations. So the standard ones we see with the international one are no sharp edges on the hose connections. It's got to be earthed, and drivers should be trained. I mean, that said, Mike has been providing driver training pretty much from well, certainly for a couple of years. And we're just talking beforehand, and I would say I'd be surprised if half of those 38 traders have actually put a driver on the training. So, and we know that the main players, like the people who are on this webinar, do. So the ones who are probably least knowledgeable are the ones that aren't doing the training, and I wonder how they're getting audited and passed correctly because they won't be equipped to do their own in-house training properly. The sharp edges, actually, we just used to use a standard thing that Feldbinder supplied. Mike picked it up when we were trialing one at Feldbinder, and you have to say the standard connectors have a 90-degree angle inside, and since that we've been getting them beveled off specially. And that is supposedly part of the N+ standards to get rid of those sharp edges. I'll be surprised if many people are doing that. And again, if they aren't doing that, how valuable is the audit? How well is this actually being checked? Where we've differed, the UK has differed from the international versions, was a number of them. So the international version says, when vehicles other than silo trucks are used for end-user deliveries, only equipment can be used that guarantee a careful delivery with a minimised generation of fines. The UK version cut that out. You wonder why it's necessary to cut out the phrase, only equipment can be used that guarantees a careful delivery with a minimised generation of fines. It's because there was a determination to remove reference to silo trucks, and for me, this is, I think people know, this is highly contentious and something we need to look at, and we will probably leave N+ or support a move to change N+ that changes that. Likewise, the international version says you need rotary feeders. Sorry, you must not have rotary feeders for end-user deliveries. Of course, that would affect all tipper blowers, so the UK cut that out. It says you should have gauged on-bore weighing systems. Again, not all old second-hand cheap tipper blowers had them, so the UK cut it out. It says you should have a suction system, effectively. and the UK cut that out because, again, tipper blowers, it's harder to find space for the suction system. So near enough, the whole thing was emasculated so that people could use any old cheap second-hand truck they wanted. Complaint management, I dare say we all know how this works. The key point is, first step is always testing the reference sample. You should really do it at the testing body, but that costs money. So I don't know if other people do this, we offer the customers, if they want it tested at the testing body or in-house, and if it's done at the testing body, there's a cost, and if the pellets are in spec, then someone's got to pay that cost. If they're out of spec, the cost is on us. It used to be that the UKPC would cover that cost, but I believe we'd never finally agreed whether that is still the case. And that, the reference sample, is the final determinant. There's nowhere else to go on most of the characteristics. But on fines, we know in theory you can take a representative sample from the store, but how many times do you get the conditions which makes it possible to get a genuinely representative sample from the store? So it is very limited, and the UK's chose to make it even more limited, but I think in this case with some reason. So we know, and Mike has taught us, that actually distance is not the key factor. It's the number of bends and obstacles that are the key factor, and the UK's special rule reflects that. And we all know the last resort is a complaint to ETAS, who I think manage that pretty well. Auditing.
1 minute remaining.
Okay, well that's near enough the last slide, so that's good. Auditing, I've been saying it all along. I mean, those of us who are involved in this know what's required at auditing. I know from our audits that really it's not a meaningful check. It's a paper check. And it's not even required every year, it's required every 3 years for traders. And it's quite clear from the number of people who've managed to get rubber stamped that there's no meaningful check. So the two problems with M+ are the standards are weak generally at the international level, weaker still in the UK version, and then the enforcement is pretty much minimal. So for traders, from my point of view, it's pretty much a waste of time. That may explain why in some countries the proportion of the industry that's accredited as a trader is very low. It's the producers generally that accredit. I put a slide in about sustainability. We all know sustainability is pretty much irrelevant to M+. It's the BSL that matters to sustainability. So that's the slides that I've got.
Thank you very much, Bruno, for your presentation. We will now change over and see. So hopefully you should now all be able to see. Good, very good. And I'll now unmute everyone, and we'll open up for questions. And hopefully we'll have a good Q&A session for the next 13 minutes before wrapping up and ending at 3 o'clock. It should also be noted that this session is being recorded, and you will all get the recording sent to you, available for download after this session ends today. And we should now have muted everyone. Unmuted everyone.
They unmuted my laptop.
You are now all unmuted, so we can all hear you and all everything you're saying. Do we have any questions for the two presentations today? Can I ask you to either turn off your mic if you are having a noise in the background? You have a lot of noise at the moment. Is there any questions for any of the speakers today, any of the presentations, any comments you'd like to make?
It's Hugh Montgomery at Land Energy. Can you hear me?
Yes, Hugh.
Hello. Quick question, well, sort of follow-up point for Bruno with regards to pellet length. And it's a perfectly sensible point to raise, you know, vis-a-vis the handling equipment at the boiler ends. If you've got a 50 mil suction system, and your natty little diagram did illustrate the point where, you know, clearly 40 mil tolerance, even that potentially can bung the system up. It's not something we come across often, but we certainly are aware that we will have supplied over-length pellets over the years. you do occasionally see them, but we very rarely get any negative feedback. But I really genuinely don't know how you avoid pellets at that length. We do know some of our competitors have put in not breaker bars, but systems that effectively catch the overlength and then break those overlength pellets and then integrate them back into the flow. But even there, I'm told that they regularly miss the overlength pellet. So I don't know there's an easy fix for this.
Exactly. So should the standard just recognise that then here?
Yeah, I'm afraid we've just taken a fairly pragmatic approach, and if anybody phones up with a genuine issue, then we take a view on what's been delivered. But it generally affects much smaller systems, and it generally is bagged sales where we've seen it over the years. But mercifully, very limited the quantities, and we just have the breaker bars within the mills, and that seems to be a pretty satisfactory way, although we have to be very careful. We do test our pellets every hour, so we are on the case every hour, and that's one of the main parameters that we're looking at. And I'm not entirely sure how we would get around this other than the industry, the manufacturing side, the boiler manufacturing side of things, changing the spec on the pipework. But this must be a Europe-wide or an international problem. It's not just going to be a UK issue.
Absolutely, that's really useful. It's just useful to confirm that probably you will never prevent the odd one getting through. I think we all know that. The question is, what does one do? Because I mean, we all deal with it that way. You get an occasional problem. It's only really a big issue if you get a flood of it, but you get an occasional problem and you fix it. But we're a small industry where a handful of these is a material proportion of the market in the sense of reputation. So if pellets have a reputation that every now and then the thing's going to break down, it's not good. Really, we ought, or at least there ought to be the easiest way of dealing with it. I suggest what needs to be done is that all systems should be designed on the assumption that it will occasionally be vulnerable to a blockage. So, for instance, if you've got a suction system, you ought to have a little screw that feeds the suction system, A, to give a chance of breaking the pellet, and B, to bring the suction system out to where it's accessible so you can very easily unblock it.
Yeah, you need to get into the key sale.
Good.
Athel's our only equipment person here. I don't know what Athel thinks about
that. Any questions for anyone else? Maybe Mike, do you want to? I have a question for you. In terms of what Bruno has presented and kind of seeing the practical implication, how it's implemented in the real world, what do you see are the main kind of shortcomings with the current certification of the EN Plus scheme, for example?
To me, there's two aspects. One is the total inadequacy of the current tests that are commonly used, and the other one is the total inadequacy of sampling in cases.
And Bruno, the same question to you. What is the main kind of issues with the current certification scheme, EN Plus, as the only one used in the UK?
Yeah, I mean, exactly what Mike says, but I think enforcement as well, which obviously that isn't part of the process that Mike would see, but we have no meaningful enforcement. The audit isn't really going and checking every vehicle. For a simple illustration, you have to fill out a data sheet for every vehicle that's used, but there's no way of knowing whether anyone's done that. And without that, how does one know whether someone isn't using a totally inappropriate vehicle for some deliveries? Actually, probably what should happen is all the data sheets should be published so that customers can check when they get a delivery, is this a registered truck? And then we'll occasionally get a report, if I had a bad delivery, it was this truck, and we'll catch people doing it. But, yeah, I mean, the sampling techniques are no good, some of the tests are no good, some of the recommended operating procedures are no good, and the enforcement. Apart from that, it's great.
So what can you name that is right then, Bruno?
I agree. That's why I'm saying if there's either a move to greatly strengthen it, or if there's an alternative that comes along, we will take either of those options, because I think N+ is now dead. It's been allowed to be so loose to get as many people in as possible that it is effectively useless.
Yeah, I'm going from the length and we supply your wood pellets to the miner. Hello there. It's just a confirmation call that transport.
Someone's got their thing going on in the background. We can hear your sales.
I think it is Steve Duff. Steve, I'm going to mute you now. If you have any questions, you can write them down and we'll take them through that. Good. Is there any other questions at this point to today's speakers and presentations as well?
I have a question. Lucy Clark from LC Energy.
Hi, Lucy.
Hi.
Hello, Lucy.
Hi. Hiya. I just wanted to ask, where are we at? I recall last year at the last UK PC Council meeting, when HETAS were present, we talked about getting to the stage where the installers would also have to be certified, and certainly with the pellet handling course that you mentioned, Bruno, that the drivers are required to attend. Where are we at for the boiler installers to be taking that course? Do we know?
Well, you know, we and Mike put together a series of courses for installers and took it around the country, and we got extremely poor uptake. That was in a better time as well. It's more than a year ago now, isn't it? You know, nowadays I think you'd have a really hard time getting installers to commit to anything, because we know, to be fair to installers, they've had a terrible year, if not 18 months, and they will be looking at every penny. Right now is not a time really to be looking at trying to persuade people to take extra costs on in any regard, I suppose.
Yeah, only that when we have those inadequate installations that cause even more pellet breakage up, that's us giving the bad news to the customer.
Yeah, totally agree. I mean, you would get some of the good players like Reheat will say, funny enough, there's a business to be made out of that, and a large chunk of work that's out there because installations are dried up is for genuine experts like Athol and Reheat to go and fix those things.
Yeah, yeah, okay. Thank you.
Good, very good. I'm conscious of time, so I thought if there's any, maybe we have time for one or two more questions. If anyone wants to raise their hand, you can, if you are unmuted, then write in the chat box or the question box.
How about someone, because I mean everyone here is knowledgeable, so rather than a question, you don't need to ask generally, you might ask Mike a question, but you don't need to ask me a question, but you could try being, you know, suggest something we should be discussing as we're all here.
Yeah, we would welcome any comments as well. Good. Okay. I think we will then leave it at that, and instead say I'll just mute everyone now. Just a moment, please. Good. Thank you very much, everyone, for attending today's webinar on biomass fuel quality. This is the first webinar that the WHO is having on fuel quality in general, and we will next week we'll have a second webinar, which is taking place on Tuesday again at 2 o'clock from 2 to 3 as today, and just to illustrate to you the where you can register. If you've only registered for this session here today, you can also register for next week, where we have Will Richardson from the Rural Development Initiative speaking about wood chip and their calorific output from different species, moisture content, and impact of chipping in general, and Helen Bentley-Fox from Woodshore talking about certification and chip quality in general. As of when the session here ends today, we will send it around to all attendees, and you obviously are more than welcome to contact any of the speakers. And as Bruno said today, most of you know each other anyway, so I'm sure that's not a problem. If you should have any questions about the webinar itself or any questions for the Wood Heat Association, please feel free to get in touch after today. I'm sure you all have my email address, but if you do not, it is faskov@r-e-a.net. And otherwise, I'll just say thank you very much for attending today, and I hope you have a good afternoon as well. And thank you also very much to our two speakers, Mike and Bruno, for presenting today. I'm sure it's been very useful and very valuable. If nothing else, might be something you haven't heard before, but if nothing else, it's good to be reminded of it. Good. Thank you very much, and have a good continued Tuesday.